So I would very much like to welcome everybody to this second session of the autonomous ship reality. I don't know if all of you have attended the first session. It was held like 1 week ago on March 12th. And today is the second session in which we have another set of very interesting talks and presentations. I will begin. Then the presentation from Maxime will follow on practical experience of autonomous navigation in commercial operation. Then from MetroStar Management, my fellow Greek, Matthew Macheras, will discuss on current issues in maritime AI issues. And we will conclude with a talk by Sean on the emerging US maritime autonomy market and current legal framework. So before starting, I would like to remind to everybody that this is an event organized and held by the BS Group. And the second session, today's session, is sponsored by a navigation promotion center, Marinet. So a few words, I will start sharing my presentation, and I would very much like to thank all of the speakers and all of the attendees for following today's session. So I will, let me just share my session, my screen. Very nice. Share screen, entire screen, window. Very nice. I guess that now you can see my presentation. Thank you very much. My name is Nikolaos Pivedikos. I come from the National Technical University of Athens, School of Naval Architecture and Marine Engineering, and I'm an associate professor at NTUA. I head a group. The group is called, as you can see on the right-hand side, along with the logo from NTUA. I'm heading the group titled Maritime Risk Group, and our group is mainly focusing on safety analysis, environmental impact, and the human element, and how this is involved into the chain of marine safety. We are also dealing a lot with issues of resilience, of sustainability assessment, and in general, we are assessing the maritime transport and the bigger ecosystem. What we are doing is what we call it is an ecosystem design process. So a part of it is also the introduction of autonomous ships and autonomy within the maritime chain. So today I will be talking about navigating into the future, and my presentation, my talk is mainly focusing on safety, so assessing safety in autonomous ship systems. Okay, so the timeline of mass development, it is very interesting. Because you can see that there is a parallel development in terms of industrial development, but also in research and academic developments in which we are trying to introduce new issues, and we are trying to follow how these are being implemented within the industrial timeline. So you can see the upper part of the slide. It is exactly on industry, and in this sense, what we are trying to do is give some changes from 2012 towards 2024. You can see that we had the switcher Hermon with remote control. Then there was a big discussion about Yara Birkeland, which has started the manned operation, and it's about to start the remote controlled one. Then you can see various small vessels like Nelly Bly, however, with a long voyage, and we go up to 2023 with Prism Courage and the Hyundai Maipo in the Singapore, in the waters of Singapore. On the same time, we have a series of projects starting. They have all started by Munich. And then you can see the DNVGL Revolt, which was a concept design and study, Rolls-Royce with the advanced autonomous waterborne applications, Autoship, Moses, and Aegis in 2020, the two sister projects. Then the Seamless, and very recently the Autoflex and the Formax projects. These are mainly, the research part is mainly focused on European research. So we have some major challenges for the adoption of the maritime autonomous surface vessels and ships. We can have some categories like the technological readiness. It's it's less of an issue since multiple research projects develop the required technology. So there is a big trend and a big belief that the technology is there or almost there. We have what we call the operational unknown. So how will remote control be exercised on a ship, on a port or port equipment, and how all this will be integrated into a broader supply chain, because we are following, an approach of system of systems. We have the regulatory complexity. Regulatory complexity may be a showstopper. So we have multiple international regulatory gaps and lack of standardization. This is very important. And standardization also not on technology and on, on this kind of stuff, but also on a credible risk analysis framework for this type of vessels, for the mass vessels. We have an issue of the additional cost. Automation and the higher level of degrees of automation bring along, costs for ports, for terminals, and also for the development of risk control or risk of remote control or remote operational centers. We also have some discussions on the readiness by the stakeholders. So we must be thinking about the social acceptance of autonomy in maritime operations. So altogether, evaluating the safety risk of mass seems to be a very challenging, a very big challenge, a very prevalent challenge of the whole system. So how much safe is safe? I mean, how much safety is enough? We have some problems regarding with what we are used to do with the safety analysis. We don't have accidents. There's an absence of accidents. So we have to deal with something that we do not have accidents and records. And on top of that, we have not defined what is the acceptable risk. Altogether in shipping, in the maritime transport, this is a very big problem, the acceptance of risk and the level of the acceptable risk. However, in this type of vessels, the mass vessels, this becomes even more important. So safety is related to amount of risk we are willing to accept, and ultimately risk acceptance tends to be, as we all understand, a societal problem. So different stakeholders may have a completely different perspective on how much safe is safe enough. So imagine from one perspective, we have the regulators and authorities. From the other, we have owners and operators. And of course, we have the general public, which means that this is a quite complicated puzzle to solve. And you can see on the right-hand side, according to the IMO FSA guidelines, the alarm principle that we use in order to define, the areas of acceptable risk or negligible risk, of intolerable or not acceptable risk, and of course the as low as usable practicable area of risk, which is the in-between area between the lower and the upper limit of safety. So autonomous ships will need to be safer than conventional ships. Why do we need to do that? Because making autonomous ships the starting point is very important. So making the autonomous ships safer would also make them more attractive to stakeholders. So, the issue of trust is very, very, very important here. We have a couple of uncertainties here, as you can see on this slide, in the sense that we have the cost, from the side of the cost. Potentially, we will have higher generalized costs in the sense advanced automation, shore control centers that should be developed, less personnel, but it might be more expensive in the sense that we need much more, qualified people to work here under this umbrella, the MAS umbrella. And of course, we must be very careful not to put a stop on the development of this industry. So we will be extra careful not to lose, the reputation that might be in jeopardy in case of an accident. From the side of benefits, generalized benefits should also increase, and as we understand, one of the main benefits could be safety. So there is a paradox here in any case. The paradox is why we're expecting so much from the introduction of automation and from automation than we expect from the humans. According to the formal safety assessment, there are 5 steps that should be completed in a formal safety assessment process, on a safety analysis or on a risk analysis. So we begin with a hazard identification where we find what can go wrong. So we must identify hazards relevant to the MAS ConOps, and the MAS terminology is crucial for standardization here in order to understand from the beginning what hazards and what this hazard mean. Then we have the actual risk analysis where we determine how likely a failure is and what are its consequences. So we can understand that here we need, for example, risk acceptance criteria that have not been established, and the level of autonomy or of automation, let's say better, has an impact on the selection of the risk analysis method per se. We continue with risk control options. So imagine we are talking about risk control options for MAS. Consider all relevant risks to proactively avoid sending off contingency systems. We continue with the 4th step, which is the cost-benefit assessment. So identify and compare benefits and costs associated with the implementation of each RCO. And this can be done with the development of disruptive business model for MAS. And finally, we have to provide the decision-making recommendations. So evaluating the safety and reliability of MAS present multiple changes, and we might need standardized risk assessment techniques and sometimes perhaps a fresh look at safety analysis and risk assessment. So, on top of all that, so we're talking about technology, we're talking the new vessels, we also have the human element. And we must understand what will be and which will be the role in the context of safety. The more advanced a control system is, the more crucial may be the contribution of the human operator. And automation changes the tasks it was meant to support. It might create new error pathways, shift consequences of error further into the future, and delays opportunity for error detection and recovery. So we might be talking about a new scenery here. Humans will never be out of the loop because there's an ongoing discussion on that. Issues relating to system trust, I have already mentioned that, as well as the skills required to develop, operate, and maintain such technologies are of utmost importance. And of course, understanding how and where humans fit into the operation of autonomous marine system is also a very important chain, a link in the overall chain of marine safety with this new type of vessels. So, if we focus now on risk, the safety and reliability of MAS will be critical for their successful adoption, goes without saying. Since 2011, more than 400 papers have been published on the domain research exclusively focusing on the safety of mass, and the approaches presented in the following slides have been developed for evaluating mass safety during the design phase, the operational phase of the vessel, and of course, we are talking about the interaction between operator and the mass. It's a very nice and interesting concept called constrained autonomy. So let's go very quickly through various risk models. We begin with DNV's risk-based assessment tool, RBAT. This was also presented at EMSA in the respective study. So with this approach, the rationale is that an accident or a failure causes system to deviate from normal or safe state to an abnormal or unsafe state. If you can see on the left-hand side at the slide, you can see that here now risk does not have the two traditional dimensions, which is probability or frequency and severity, but it's actually the severity dimension remains, but now we have a new let's say, dimension instead of probability or frequency, which is the effectiveness of risk mitigation layers, and it goes from low to extremely high. So we have a new let's say definition and implementation of risk exactly to cover the new reality of the mass. Another model focuses on supervisory risk control, and this is done by the combination of this is a two-phase process, combining the hazard identification and analysis through STPA, which is a systemic theory for identifying hazards, and the development of the risk model represented by a belief network or a Bayesian belief network. So the two approaches to supervised risk control suggested control based on real-time feedback and optimization through predictive control. So with this approach, it's a combination of a systemic methodologies in order to be able to devise and define and formulate on the right-hand side of the figure, the so-called risk model. Risk-based path planning. So there is a lot of work done on the utilization of risk as a prevalent factor for path planning while avoiding collision with other ships and grounding. This is exactly for mass vessels. Development of a dynamic probabilistic risk assessment method, and provide a holistic picture for a mass, allowing it to consider several aspects of risk. So this is another model that is being used. And we can continue with the fail-safe approach. Fail-safe approach is very, very important. This application here is on autonomous tugboat safety, so set the foundation for the fail-safe functionality of an autonomous tugboat swarm to maintain the safety of the maneuvering operation in case failure occurs and prevent the escalation of the hazardous situation in case of failure occurs. And you can see there is a four-step approach. The STPA, the systemic methodology is used again, and it's a very nice way to understand the process and identify potential hazards. And we can go even further. We have what we call constrained autonomy, which is a design-in limitation on the possible action of an automation system in a mixed autonomy and human operation context. Here, we must develop what we call as the operational envelope, the specific conditions under which a given autonomous ship system is designed to function, including but not limited to its environmental conditions and the different mission or voyage phases, as well as all the anticipated failures. And in this case, if something goes wrong, then we must be able to, let's say, to achieve the fallback to a minimum risk condition, a boundary where the fail-safe procedures need to be activated. So the let's say the definition of all these phases and the interaction between the various parts of the system is very, very important. And it can go even further. We have, as NTUA, we have introduced a so-called bio-inspired safety of mass. Imagine that the vessel or the system is considered and is viewed as a living organization and a living organism. So what if by knowing what is normal, the autonomous ship could understand on its own what is abnormal? So if we are talking about self, the vessel could understand, or the autonomous operation could understand what is non-self. So an autonomous ship can be viewed as an organism with integrated process for regulating its health, and this can also be done in the various life cycle phases. So we can see that there are a lot of methodologies that focuses on risk models, on the assessment of safety. Risk assessment for decision making remains a main theme in the research domain of mass. A major concern related to mass safety is operation in mixed navigational environments. We can have combinations of existing or of systemic approaches in order to study the risk analysis on this kind of ships. And of course, the interaction between the remote operator and the ship will be a critical safety factor for mass implementation. Closing my presentation, it is very important to understand that when we're talking about mass, we are also looking towards the shore in the sense of the remoting, monitoring and or control of the vessels. It is very important to understand what qualification will remote operators need and how will they need to be trained, and whether remote operators have adequate situational awareness. Situational awareness, it's of utmost importance here. So there have been relevant research on that, and the research and the tool, the CHI tool, is based on system theory approach, identification of stakeholder and technology roles, and the mapping of gaps and challenges related to autonomy. So we have also done a lot of work on that. You can see another methodology that we can use is SysML, on which we can have the design within the loop, so we can see the various interactions of the various players and functions and check how we will be producing. There has also been work done on by ISO 23860 on autonomous ship vocabulary in order to understand the various, let's say, definitions like the acceptable risk condition or the minimal risk condition that we have also used. Instead of conclusions, so mass will need to be safer than conventional ship, but what will it take for them to be safe? One, we must address the uncertainties. This is of utmost important. So you can see various points here, new risk introduced by automation, whether we will have the mitigative potential, and the human element might not be there in the conventional, the traditional way, and how this will affect the whole thing. And of course, we will need to verify and validate all safety levels and safety proportions. So we have heard about various terms here, and other term that might be introduced is the system fragility, in case that we are looking about ultra efficient automation. And a second point that we must always keep in mind is that we must choose a strategy. The strategy might be that the humans stay in the loop, the constraint autonomy that we have mentioned earlier, so the ship solves all standard problems, but an operator starts and it's focusing on solving the complex problems. Or we can start, and at some point this might be the case, but this might not be the near future. The autonomous ships become more and more autonomous, so it deals with a lot more different situations on their own, depending on, of course, on the automation level of the vessel. I would like to thank everybody. The presentation might took a little bit more and might be a little bit more technical, but we wanted to show the complexities and the work done on the assessment of safety and risk analysis on mass vessels right now and what's going on. And I would like very much to thank everybody. And at this point, I will stop sharing the screen. Stop sharing. I hope that now I'm not sharing the screen. And thank you very much. I see that there are some questions on the chat. I will give, because the presentation took a little bit more, I will give the floor to Maxime in 1 second, and I will try to type and answer in writing all the questions. I would also urge all of the next presentators to do the show, but I will also try to ask a couple of questions from the ones that I see on the Q&A. So following my presentation, let me just say that shortly 2 questions will pop out. We have an online poll on this session. The first question will be, how familiar are you with the concept of autonomous ships? And the second is, what do you perceive as the greatest benefit of autonomous ships? So I would like, very nice. I would very much like, everybody, and I would propose to everybody to complete this, and that at the end, we will present the results and ask from the panel, from the presenters, from our esteemed colleagues to comment on the replies given by the attendees and by all of us. So at this point, I would like to welcome Maxime for his talk. The talk is titled Practical Experience of Autonomous Navigation in Commercial Operation. Maxime comes from the sponsor of this session, as we said, from a navigation promotions center, Marinet. And Maxime is the leading expert of the A Navigation Promotion Center, Marinet. The center aims to push high-tech technologies for autonomous shipping to international market, and at the same time working for regulatory development to make implementation of autonomous navigation smoother and efficiency. He has worked as a science worker at the Federal Research Center for Project Evaluation and Consulting Services, where his focus was the development of expert system for selection and presence of scientists project for financing. And he holds, from his academic background, a PhD degree in economics. He was graduate in Russian Technological University, Mirea, with degree of management. And last year, he has presented autonomous navigation in various national and intergovernmental committees, including multilateral cooperation and international organizations. So, Maxime, the floor is yours. And once more, I would like to thank all the attendees for being with us, and urge them. We would like to make it as interactive as possible, this session. So please ask and use the Q&A tab in order to proceed. Maxime, the floor is all yours.
Maxime, do you hear me? Do you hear me?
Yeah. Now we can hear you. Yeah, go ahead.
Yeah, you can hear. Yes. Dear guests, who are fans of autonomous navigation, probably, I think. I would like to express my gratitude for to BS Group for the opportunity to take part of the conference. And I'm glad to present for you today the recent developments of autonomous navigation in Russia. I will not spend much time about the importance of autonomous navigation. Also, I would like to add that autonomous navigation is in the light of the shipping industries all over the world, as Nicholas already said, and the global industry comes to the stage of wide use of autonomous navigation in real commercial conditions. From the previous presentation during the previous days of conference, we can see the most valuable cases of autonomous navigation experience. And also autonomous shipping could have a significant impact on the environment, particularly in terms of reducing greenhouse gases emissions and providing the sustainability of the maritime industry. And I will describe about our experience in more detailed way. In 2019, the group of Russian companies has started the autonomous and remote navigation trial project is 5 years ago as the world's largest trials in real commercial operation. And the aim of the project was to open opportunities for every shipping companies to try to implement autonomous navigation solutions to facilitate the technology development in this area, to bring this technology to the consumer's hand. And in spite of the technology feasibility of autonomous navigation was proven during many experiments around the world, we had to deal with the several big considerations. First of all, the system shall be predictable and transparent for all participants. So safety, as told Nicholas. These solutions shall fit to existing international regulation. We actively working in IMO on joint development of mass regulation. As maybe next speakers will explain, the mass code will be adopted, planned to adopt it at the end of this year. The first version is of the code. And the technologies, the third one is the technology shall be affordable for the shipping company, in contrast to previous experimental and very expensive solutions, killing ship owners' economic benefits by their cost. And the common answer to all these three considerations is the principle of complete functional equivalence, the methodological basis for our developments in autonomous navigation. To ensure this principle, in-navigation system projected on the current function fulfilled by the crew as it provided in STCW convention and other regulation, and it's make it possible to ensure a gradual process of introduction autonomous navigation technologies by shipping company when depending on the level of automation of ship processes. Certain function can be excluded from the set of function performed by the crew members with a corresponding reduction of the ship's crew. The following three level of legislation, I hope the next speaker, Sin and Matthew, will add about legislation in autonomous navigation. In Russian was developed three level of legislation to ensure widespread operation of the mass under the current international regulation. Last year, in July 2023, the federal law was adopted, arising from the use autonomous ships, and it will come into force in this year, probably in September, because during there we was not have such federal law. We use government decree on national experiment on use autonomous vessels under the Russian flag for transitional period until 2025. The third one is technical regulation of autonomous navigation, means guidelines on the classification of mass by Russian Maritime Register of Shipping, and the recommendation for CalReg 72 application in automatic control system. I want to add the main innovation of the federal law. It allows to use autonomous commercial vessels from any foreign countries use in territorial water of Russia. I spent a couple of words for the set of solutions following the complete functional equivalence principle. The architecture, the technical solutions was developed. It consists both traditional, marked by gray box system, and the new solutions. The new solutions, only free one. This is autonomous navigation system, optical surveillance, and remote control system. You see in the right side the photo of this system. The first one is autonomous navigation system. It performs the functions of automatic analysis of the environment, the passage along a given road, offering automatic decision making or maneuvering while taking into account parameters of the vessels and CalReg 72 provisions. The next one is optical surveillance and analysis system. The system is optical and optical system that detects and recognizes surrounding objects. It transmits this data in a machine-readable form to the autonomous navigation system, while also sending the preceded video image to the human interfaces, such as remote operation center and bridge advisor. And the last one, this is the remote operation center. It locates outside the controlled vessel, and it is equivalent of a highly ergonomic ship's bridge and central control station. I want to add about the trials operation, which was means during the experiments since the early 2010s. The Russian Federation has been worked on developing the autonomous navigation technologies for the commercial vessels. The world's largest autonomous and remote navigation trial project successfully completed in 2020 first, and since then several commercial vessels has been used autonomous navigation system. The project involves the following commercial vessels. As you see, this is Рабочая motor barge owned by Rosmorport, currently operated in the Black Sea. Pola Anfisa, general cargo ship owned by Polarize, operating in the Mediterranean and Black Sea. And Mikhail Ulyanov, shuttle tanker owned by Sovcomflot, operating in Barents Sea. in Arctic. More than 70 voyages with autonomous navigation trials were made. Over 100,000 simulated tests are provided during these voyages, and 10,000 operations recorded. And we came to the national experiments of autonomous navigation. This is a commercial operation, and we have two Russian largest railway vehicle ferries, Marshal Rokossovsky and General Chernyakhovsky. Now is the first ships in the world officially certified with mass category with onboard crew reduction. Certificates were issued the September 25 and 29, 2023. These carriers operate on more than 500 miles road between Port Baltiysk in the Baltic Sea and Ust-Luga. Each vessel about 20 meters long. Mass category takes by register of shipping. It allows navigation under remote control with manual control override capability when moving in the sea, and manual control with the use of autonomous navigation system for decision support when moving in the restricted water and the entrance to the port. Within the national experiments, any shipping companies from any country is allowed to equip with autonomous navigation system. Any vessels under their state flag is legally operated with MAS in commercial conditions. This is remote operation center. It is located in the airport, St. Petersburg. The center provides monitoring and surrounding navigation situation, control the main movement or parameters of the ferries, as well the remote control at the open sea. And I want to know the extension of commercial operation of MAS, flying the Russian flag, and the importance of human elements for safe MAS operations. Require qualified personnel for MAS use. To meet this need, in September 2022, the Ministry of Transport in Russia developed the set of advanced training program, personnel based on the applicable standards, STCW convention, and MAS code, and taking into account the practical experience of MAS use in Russia. The purpose of the program is train masters and crew for the operation in the semi-autonomous vessel, and to prepare the remote crew to operate full autonomous vessels. By the end of 2023, the Russian University of Transport trained 40 autonomous ship operators. They work or the ferries, that means the previous slide. And the proper simulator is developed for simulation of navigational conditions, MAS system, and remote operation centers that allows to train MAS personnel for various conditions and scenarios. The first simulators are deployed in Russian University of Transport, and the second simulator was deployed in October 2023 in Admiral Makarov State University for of maritime and inlet shipping in St. Petersburg, Russia. That is all from my side. Thank you for the attention. I'm very interested in your questions. Thank you.
Thank you. Thank you very much, Maxim. Very interesting presentation. It's very nice to see, from the practical side, from the industrial side, the developments and how things are being implemented and how things are proceeding. you mentioned about the testing of the two vessels at some point. What were the most notable findings or highlights observed during this trial? So, what is your experience from what you have been doing? The main challenges for introducing these kind of vessels in a in a more mass effect.
Yes. I want to add that two ferries. It is not trials. This is a commercial operation. This is work in the two mode. It is autonomous navigation and remote control mode. This is regular ferry. This is not trial. Trials was in the previous step when I shown the three vessels, which was dredger caravan. Very interesting solution that the dredger, the remote control station of the barge was deployed in the dredger, and it can the barge can operate from the dredger. That's why this is the first example of autonomous navigation caravan. This is very interesting solutions. And also we have a huge enough vessels. This is shuttle tanker. It is pretty big enough for the operation, and the Barents Sea. And also we have a general cargo ship that operate in the Mediterranean Sea.
Okay, very interesting. Maxim, are you okay? Now we have the vessel, and as I also mentioned, and you mentioned, we have the remote control or operation center or whatever. In the simulation, have you developed a special type of simulator to to deal with the ship and the remote cooperation center, or you are performing everything to a to a standard simulator? And how do you integrate the remote operational center or
Yes,
into the process?
yes. This remote operation center, it is not the training. It is not a simulator. This is the copy of the bridge, which takes the picture from the ships, from the cameras in a live picture. And a captain sitting in the office making decisions. In this outstanding bridge, this is a remote operation center.
Yeah, but Maxim, how did you train them for this remote? Do you have a special simulator?
Yes, of course. Yeah. This is different solutions. This is the simulator. We developed the I'm sorry. We developed the solutions. Yes. We developed training solutions and add to that the different kind of scenarios which can find when the when people who are operating mass can see in the real life. That's why we can see the different kind of scenario when the one mass ships see the other mass ship. When different kind of weather solutions as the standard standard simulators, but maybe the new one option. This is the
yeah. Maxime, I'm getting a lot of questions, and I would like you to elaborate and clarify a little bit. The two vessels in the Baltic that you mentioned, are they fully autonomous? Are they remotely controlled? Do you have people on board during their sail? Can you clarify a little bit on that?
Yes. This is the ships which works like ordinary ships. This is like a ferry. It includes the trains or cars, and also the owners of the cars who are located in this ferry. That's why this is this operate like standard ships. And I want to add from the previous question that we developed the simulation environment, and this environment allows to switch on the probably navigation system of the new one autonomous mass ship, only navigation ship, to test it. That's why this is not only the simulator. This simulator allows to test some parts, some developments for the autonomous, because it's very difficult to make a new one. Ships build the new ships to test it. We can install only not need to install to real ships. We can switch on this simulator. These simulators, like a tester, can make scenarios to test all new one solutions.
So there is crew on board these vessels.
Yes, crew. Yes, I come to your question. The ferries has crew, but with the reduction in 30% as prescribed the regulation, with the exception of Russian register of shipping.
Okay. Thank you very much. I would like also to remind you that I try to bring to your attention some questions that are already on the Q&A. So please go on the Q&A and try to reply in writing to any questions that you deem appropriate to reply and that we haven't covered. Thank you very much, Maxime. At this point, I would like to say that I have closed one of the two questions from the poll, and another one is still up in the air, and we will add a third one, which is what do you perceive as the greatest challenge of implementing autonomous ships? So very, very shortly, this will also pop up, and please, I would like to urge and encourage all the attendees to participate into the polls. And at this point, I would like once again to thank Maxime. Thank you very much, Maxime.
Thank you.
And we will continue with my fellow Greek, with Matthew. Matthew, are you with us? I cannot see you. Matthew? I expect a message from the administrator, because it seems that Matthew because he was with us at the beginning, but I cannot see him or hear him. So in order to gain time and see what's going on with Matthew, I will pass the floor to Sean. Sean, you are coming up sooner. Sorry for that. Your son is coming from Holland & Knight at LLP USA, and he will be talking about the emerging US maritime autonomy market and current legal framework. And this might be very interesting. It will be very interesting because, as I said, the legal aspects are very much into the spotlight. So Sean is a business attorney in Holland and Knights in Washington, D.C. office. He focuses his practice on maritime regulatory compliance matters, autonomous transportation and emerging technologies, environmental law, international trade and sanctions, renewable energy, offshore wind infrastructure projects, marine claims, civil litigation, and white-collar criminal law. He is a proctor in admiralty with the Maritime Law Association of the United States, where he serves as chair of the Autonomous Ships and Smart Marine Technologies Committee. He also serves as a senior advisor to the World Maritime University, Global Ocean Institute, European Union's Horizon funded project titled Overcoming Regulatory Barriers for Service Robotics in an Ocean Industry Context. This is the back right to project. I think I don't know, Sean, I don't know whether you were also in Greece. I attended,
Yes.
Yeah, you were there here, eh?
Yes.
About
Yes.
2-3 weeks ago.
Yes,
One
Piraeus. Yes.
in Piraeus. Okay, I was there, and so I am aware of what you are doing. Okay, so thank you very much for being here, and we are waiting for your presentations with great interest.
Yes. Thanks very much, and I believe you can hear me okay. Are you able to see the slides?
Super. Yeah, I can see everything.
Okay, very good. Well, thank you for the invitation. This is a fantastic program. I've learned a lot already in the first couple of presentations. So what I was asked to offer was a view from the United States, and I've been dealing with the issue of vessel autonomy since around 2014, 2015 timeframe, when I used to be in the U.S. Coast Guard as a lawyer. I've seen quite a bit of change in the views and perceptions. I've seen a lot of discussion on the various, what some people would consider obstacles and opportunities as well. So the presentation here is going to focus on the United States, which is very active in the International Maritime Organization, and they really have been with the context of MASS, with the regulatory scope and exercise, very active in helping to define the degrees of autonomy. They continue to work closely with the IMO. I think we have some background noise, but if people can mute their microphone. So they've been very active on the voluntary code. They'll be they're closely monitoring what's happening, and I think that what's important to understand is how the U.S. has been approaching this, and what the easiest way to describe it is we have a strong disconnect between use cases between the defense sector and the commercial sector. So I was very intrigued to see some of the use cases from the earlier presenters on the commercial context. I spent a little bit over 2 years living in Norway when I was a P&I club lawyer. Was able to see Yara Berkland, was actually on board several years ago. So it's very intriguing to see that continue to advance as well. I would say that on the commercial side, the U.S. is very far behind. There was a discussion, I think, of new regulations in some countries, and I'll touch on this later, but the easiest way to describe it is that the U.S. is very active on the international discussion stage. They are very advanced on the defense sector side, but we are very behind on the commercial side, and I'll touch a bit on that. But that's all under the umbrella of what's coming. What I think is this is a very important year in the United States, and this is a quote from one of the Coast Guard admirals who's in charge of what's called prevention policy at Coast Guard headquarters at a recent congressional hearing that we both testified at. I'm sorry, if we can mute microphones in the background. There's quite a bit of background noise.
Yeah, yeah, I agree, Sean. I don't know whether the administrator can hear it, and if you can, please deal with it. Thank you. Go ahead, Sean.
So yes, so this was a very interesting hearing where the focus was on autonomous and experimental maritime technology. So broader than just autonomous vessels or mass. But what was interesting to hear was from a Coast Guard perspective that the Coast Guard is poised to facilitate the greater use of autonomous systems to support maritime operations. So this is, I think, in the context of the Coast Guard using the technology, but certainly they are aware of commercial applications that have been coming in the form of requests for use cases. And what's interesting in the United States is there's been a long-standing view at governmental levels that in terms of obstacles or hurdles, whatever term you want to use, is that by statute in the United States, so by law, navigation and manning laws can't be waived. In particular, manning laws. So that there is a statutory requirement that there must be at least one human on board, and this has been a long-standing view. The U.S. has taken a it's not an official position. They don't have an official position on either being advocates or opponents to autonomy. There's no official position that is available to the public. But the idea that there must be a human on board has been a significant barrier to even getting to discussions of a broader application of the technology and use cases. This all changed in my view. This is my view of what's been a very important indicator. So this is an authorization act, uh, uh, which was actually under the National Defense Authorization Act of 2023, where Congress expressly used the term waiver. You can see here in the slide, this is the screenshot from the actual act that essentially authorizes the Coast Guard to waive applicable regulations to allow remote and autonomous vessel at sea operations. So the fact that for years we've heard these academic debates in the U.S. that you simply can't waive statute. Well, here it's done. So there's no question anymore in my mind that it can be done. The rub is how it was done. So in order to get to that level of waiver, it required uh, Congress to act. And the other thing I'll mention is that is that specific uh, application was for a very narrow, essentially one type of operation, which is launch and recovery of space vehicles. So essentially, uncrewed barges that launch rockets and then recover them at sea. So it doesn't apply to the entire sector. So you have a one-off authorization under a pilot program when the Coast Guard has been authorized with. That's a very significant change to what's been at least in the academic circles and at the government level a view of what was holding things back. The other issue is whether or not, and this is an ongoing debate at the IMO and other legal associations is and government level too, is can an uncrewed vessel comply with the COREGs, so the navigational rules of the road? There's several government lawyers who have taken a position that know that you must strictly interpret COREGs that apply to all vessels, that the COREGs do not allow for they cannot be interpreted, I should say, to allow a human to be not on board. So there must be a human on board because sight and hearing are inherently human characteristics, and the COREGs never contemplated that sensors or other types of monitoring devices could be used to supplant humans. Well, this changed in 2022. Again, this is my view. So 2022, the Coast Guard signed on with the Navy and the U.S. Marine Corps in what's called the Commander's Handbook on the Law of Naval Operations. So this is a military specific document. However, in that document, signed by then the Judge Advocate General of the U.S. Coast Guard, Admiral Burt, the Coast Guard signs on to the view, which is expressed clearly in that handbook, that fully uncrewed vessels can comply with the core regs. So that applies here to Navy, Marine Corps, Coast Guard. But of course, this is all vessels. What's unique in the U.S. is the Coast Guard wears 3 hats in the sense that they are a maritime law enforcement agency, they are a military branch, and they are a military service, and they are a regulator. So they wear all 3 hats simultaneously. That's a little different than some other countries as far as what their Coast Guards may do. So the fact that they've taken this position, it's very difficult to say that a commercial vessel cannot comply with what the core regs, because there's no distinction. It applies to all vessels. So now we see that you can waive you can waive the manning requirements, and you can comply with core regs without anyone on board. We don't have anything more formal that solidifies those views. What we have most recently is February 2022. So really, we're talking now. It's been 2 years since we've seen any type of policy letter, and this is a testing policy for guidelines that still requires. What's interesting is this policy still says, well, you still must comply with the core regs, and it's read to mean you still need to have a human on board. So this was 2022. This was the next month, March 2022. So, that letter, I don't think was updated with the view of the Coast Guard that it took in that handbook. From a commercial sector, we're left guessing as far as what that means, because it's to me clear that these vessels, and the Coast Guard's view from its top lawyer, the Judge Advocate General, that it can be done. So where are we seeing this in practical application then? In the U.S., I think that right now, the most obvious area for the use of what I would call uncrewed vessels, but they're also referred to as vehicles in the U.S. This is not unique to the United States. This is a nomenclature issue across the marine sector. Currently, what we have are survey vessels that are used in the offshore context, either for oil and gas, other energy, as well as preparing for offshore wind surveys. So highly efficient. These are used in the easiest way to describe them is used to collect data. So these are data collecting vehicles. That you can see that these are rather large, getting larger, but they are defined as vehicles, so they're not obligated by the Coast Guard to comply with collision avoidance. They don't have to comply with the core regs, which state that a vessel is capable of being used as a means of transportation on water. Here you can see on the right there's a human on board that surveyor. So whether or not that is a vehicle or a vessel, that's outside of what my view here today. But I just want to raise that is these are practical applications of what we're seeing primarily on the commercial side. I mentioned the defense sector and what we're seeing. This is really where the U.S. is leading in the international voyages. So over the years, the U.S. Navy's been developing what they do refer to as vessels. So this is an unmanned surface vessel called the Ranger, one of 4 unmanned ships that participated again in joint operations, training operations in the Pacific this past year. What's interesting is that this is a part of now the U.S. Navy's vision for the future. So likely a combination of larger uncrewed vessels like this in combination with smaller vehicle type swarms, perhaps. That's still being every year. I think we have a new strategy on what that's going to look like. But just to say that what's interesting about the Navy is the legal precedent that it's setting. So these are vessels that are operating on the high seas, that are making international voyages, and in some cases there's no one on board. It's the vessel's making its own decision making. Usually they'll have someone on board who's not in making the actual navigation decisions, But these are all testing cases that are happening on the high seas. These have transited the Panama Canal. So quite a bit on the what's important there is to just recognize, while the U.S. commercial sector may be very far behind, the defense sector is really out there making international voyages, trying to set, well, I'm not sure if they're trying to, but they are setting precedent that these vessels can operate under autonomous functionality. So what's on the horizon? I mentioned that congressional hearing that I participated in the fall, and one of the main takeaways that I had were the conversations outside of the formal testimony, where I was approached by members of Congress expressing interest in this topic. I mean, the difficulty, I think, in the United States, though, is once again perceived limitations with statutory requirements, a very influential labor union market that is really has the ear of Congress. So, but I would just say that it was interesting to me to hear congressional interest in this topic. They want to know more. And again, that's why I said that this year I think will be very important to monitor the U.S., because I think we'll have more in terms of an understanding of where the market may be going. Part of this past year, an activity that I was a part of was helping publish as a co-author and committee member to this study report on the Coast Guard's next decade, where we were asked to look at Coast Guard's legal authorities over the next decade and anticipate whether changes may be needed. We had identified in that committee that the manning requirements do call for human operators. So these are issues that need to be addressed if the U.S. is going to allow greater use of autonomous vessels going forward. One of the other developments that's in a proposed piece of legislation is the establishment of a National Advisory Committee on Autonomous Maritime Systems. This has not been passed into law, but just to show you that that Congress is looking to develop more expertise, more understanding of what the introduction of autonomous vessels may mean. This just shows you, at least to me, that they're taking it seriously, that they're exploring this. They are taking a bit of a wait and see approach on the commercial side, monitoring what other countries have been doing. We don't have any pending legislation that actually changes any of the current laws, and we don't have any changes to regulations that are pending either. So the indications are that won't happen anytime soon. So everything is going to be handled on a one-off basis. So discrete authorizations for specific types of vessels and use cases, that requires the assistance of people like myself who can communicate and try to justify use cases with the Coast Guard to try to get commercial operators the opportunity to develop their business case and technology. One of the other things to look at that's expected this spring is a part of this legislation that I mentioned, is a report from GAO, which is a government office here, the Accountability Office in the United States. They were tasked by Congress to develop a report on the state of autonomous and remote technologies. That report is due this spring, I think late spring. They're going to look at quite a few things. So I think this is part of why this year's so important, because this report responds to Congress directly. I've spoken with them on this report. I know they're looking very deeply into these issues. I've bolded them here, what's commercially available, what are the risks and benefits, the issues of labor, regulatory issues. For this event, they're going to look, I think it's important to see that how the technology is being used in other countries. How have countries regulated those activities? So I think they want to see what's out there, and then we'll get a report at the end of spring, maybe early summer is what's expected. Last point I'll make is one of the motivations for advanced technology or moving cargo and people from the roads to the water. This is very similar to what Yara Berkland was built for, what ASCO has been doing as well in the Oslo fjord, and trying to move those trucks off the road and put them on vessels. There are discussions out there about how vessels can participate in this if they operate either a reduced or fully uncrewed capacity. Again, these are just discussions that need to be handled on a one-off basis, because there is not a blanket authority to do that in the United States. There's no indication, at least in the near term, that I can see that we're going to see a fundamental shift to that, where you'll get a blanket authority where you can come in and beyond that testing or through legislation to authorize certain operations. So thank you very much for your time. I'm available for questions, and I hope that kept with the time limit as well.
Thank you. Thank you very much, Sean. I haven't kept the time to begin with, so I cannot, Okay. Thank you. Very, very interesting presentation. It is very, informative, and for us that we are very much involved in the European research and European developments in this kind of this side of the industry, to see what's going on at the other side of the Atlantic. You touched upon many things. Can I ask a very naive question here? I mean, the people not on board, but the people that they will be on the remote operational or control center, should they be perceived as seafarers, crew members?
So it's something that's being looked at the IMO as well as the CMI, which is the International Maritime Association. Short answer is it depends, and it depends who you ask. So some people take a view that yes, they absolutely must be. I think that's the view of the IMO, is that anyone operating remotely would still have a qualification, whatever that qualification means. So do they need to be licensed master? Do they need to be licensed or a credentialed seafarer? There's likely some expectation there. The U.S. did have a test case about a year and a half ago, maybe longer, with sea machines where they were operating remote control off of the coast of Denmark. And in that case, they were operated from their Boston office. And those were all credentialed mariners. Those were licensed mates that were maybe even master level, that were in control of the operations of that vessel. It's also an issue that's being looked at in the U.S. in a separate work group that's an advisory committee level that has prepared quite a bit of research on that. There's no formal decision yet from the United States, but I think that the expectation, based on their participation at the IMO, is that the U.S. would expect that yes, they would be for qualification purposes a seafarer or have a license if they're in charge of a navigational watch. The issue I think that's really interesting from the legal side is how do they fit then into the employee rubric in the United States, which we have a special set of laws that apply to shipboard seamen, and so whether or not that employee would then, if something happens and they're somehow injured, in the remote operations center somehow, how what personal injury, again, it wouldn't be the same exposure as being on board, but we have a very interesting seaman personal injury legal framework. So if they are considered seamen and they're not on board, how does that work? That's too far outside of the scope of this panel, but I just wanted to raise it as it's a really interesting question.
Thank you. Thank you very much. And if I may also ask, we have also seen from the presentation by Maxime. We are we will consider them as seamen or masters or whatever, but we are talking about different level of qualifications here. They must have some kind of, I don't know, computer training or
that all has to be, taking a step back for a second, what makes this issue so interesting and challenging is that this is a fundamental shift from how ships have operated forever, which has always been built with the idea that there's a human on board. And this is a modern evolution of that concept that has really challenged all of our accepted ideas and norms and the way that the laws were developed. So what qualifications will be needed? I think it's just like any type of assessment of particular vessels that are needed for certain ships. So certain trainings needed for tanker operations, for example, that aren't needed if you're working on a bulk carrier. There are different criteria for different types of vessels. I would expect that this would require something that's a little bit different. One of the things that's interesting though about it is on the remote operations center is there's a lot of discussion about, well, this could give the opportunity to people who aren't physically able to work on board ships the opportunity to be involved with shipping. So it offers a bit more of a diverse workforce. So people that maybe how that actually plays out, I'm not sure, but when it comes to onboard experience to how many sea days, for example, you need to advance licenses and things like that. So I think those are all being considered. I don't think anything is off the table, but I also don't believe that anything's finalized yet. But I think these will all be discussion points. Last point I'll make in that is I think the U.S. is probably more. I think the expectation is that remote operations would be more accepted in the sense that someone is still in control, that's opposed to a setting the vessel on some type of predetermined course where it makes its own course corrections, things like that. If having a human still in the loop, I think is probably where the U.S. comfort level is right now. Whether that remote operations center operator needs to be licensed in the U.S. or credentialed in the U.S., that's still being discussed because that's not universally there's no universal acceptance on that yet. Some countries say you have to be licensed in the U.S. and some say that it doesn't matter. You can be a remote operator and licensed anywhere because by its nature, it's some type of distant control anyway. That once again, there's a whole slew of issues that come with that conversation. But I'll keep it at that.
Thank you very much. Once again, I would like to remind everybody to go to the Q&A for the attendees to pose their questions and for us, for the panel to, put out some brief replies. There's an interesting comment shown from Maku that you might be, willing to say a couple of words in writing when we go on with the next presentation. Thank you very much for the very interesting presentation. And before passing the floor to my fellow Greek, Matthew, who is with us now, I don't know whether you had a microphone problem. I heard, I don't know.
I think it's okay now.
Super. Yes. Before giving the floor to you, let me just mention that the two last questions of our poll will be popping out shortly. The first one will be about the level of autonomy that we think that's the most suitable for ships. Perhaps the level of autonomy might not be the correct term here, or level of automation could be much better, but this will be the question. And the second will be whether you believe that the public is ready to accept the widespread use of autonomous ships. I've mentioned about trust. I've mentioned about the paradox, or that we might be, looking for more things from the automation side than from the humans and how we control ships. So with these two questions, the poll will be concluded, and at the end we will, and I will ask from my fellow panelists to, to comment on the results that I will announce. So at this point, I would very much like to welcome Matthew Macheras, who is the Chief Information Officer in MetroStar Management Corporation, and he will be talking about current issues in maritime AI. Matthew, he is the Chief Information, as I mentioned, Officer of MetroStar. He holds a PhD in Operational Research from here, NTUA, I guess, School of Electrical Engineering or Mechanical Engineering. I don't.
Mechanical Engineering.
Mechanical Engineering. Very nice, Matthew. And an MBA from Imperial College in London. He has a wide experience in managing innovative IT projects, and typically they involve clouds, Internet of Things, and AI. And he has a special focus on cybersecurity and data privacy. Indeed, also, Matthew, when we are talking about safety assessment, we are not used, but software is popping out everywhere,
exactly.
And how this can be dealt with. So we are much very anticipating for your talk. The floor is all yours. And
thank you for the very, very extensive introduction. You're very kind. I'm here to somehow complete the vision from the angle of the user, let's say. We're not from the angle of the management and owner, right? Okay, a management company and a vessel owning company, and how we go about this. And it's a good thing that I was the last one. Can you hear me now?
Loud and clear.
Okay, because I see that I have some things to complement to the other presentations so far. Okay, let me start from let's take it from the beginning, as I said, from the user view, the one who is receiving all this, on what is AI, okay? AI refers to a machine's ability to carry out a certain task and keep improving without being given explicit instructions on how to do it. That's the difference from automation that we had so far. Examples are the well-known personal assistants, of course, ChatGPT, and Bard from Google. Having said that, there is this question. Can computers really think? That's also always popping back to the autonomous discussion and so on and so forth. And that's an interesting year we're living in. 2024, 2023 was a special year because the answer to that comes from the well-known Turing test, devised back in the 50s when Alan Turing first started discussing about artificial intelligence. And what the Turing test says is that you have reached the level of artificial intelligence if you can fool a real person believing that you are another human talking to him and not a machine. So the interrogator that we see in this drawing would not really know if it's a person that he's talking to or a machine, as we see in the picture. And what's important, that was unpassed, and for many it's still unpassed, this test, till this year. But 2023 is the first time that we get so close, and we have at least several claims that the Turing test has been passed. Let's see. There was let me get the flow right. There was a very influential article saying that ChatGPT broke the Turing test. Let's go find other ways to challenge AI in these days. Okay, not accepting that this is not actually equivalent to human intelligence. However, they claim that the Turing test has been passed. But more papers come after this saying how and why ChatGPT failed the Turing test. And this second article went into philosophical questions that, of course, ChatGPT was not able to answer, or to place it better, was commercially directed to not answer philosophical questions, okay, about existence, about if there is God, and things like that. So it's not at the human level yet, but 2023 was the year that like 99% of the abilities we were to expect from AI were met with large language model and generative AI. But what is AI good at? All the examples we saw, there's a one common denominator, and that's prediction. AI can work very well on vast amounts of data and predict what comes next, be it in navigation, be it in computer vision, be it in even market developments. Based on the data we have, we can elaborate on it and think almost as close as a human to predict what's coming next. And what do we have AI in maritime? Of course, autonomous vessels and remote command system, which is now coded MASS, Marine Autonomous Surface Ships, situational awareness and safety, route optimization and fuel efficiency, port operations optimization, and AI-powered solutions in the back office. Let me just go into what was important this last year and what's currently very hot. What we saw in 2023 was a great advancement in AI and sensor technology, with computer vision and machine learning becoming standard in many cases. We have many cases that now the yards deliver the ships with such equipment in the spec from the beginning, without even asking us, the buyers, if we want it or not. And even if we don't want it, they don't give us the money back. Okay, enhanced sensor technology like LiDAR and high-resolution cameras. I think you know at least a couple of commercial examples. Real-world testing and pilot programs from, as we heard earlier, many of those, although we didn't have so much visibility into the Russian experiments. Thanks for that. And many trials in different varying degrees of autonomy, short sea, tugs, we'll see it later. And of course, and most importantly, regulatory developments and collaborations. And here I have chosen a few things that might shed some light in what we saw in the previous presentations. Okay. So, where are we on the autonomy journey? This is the well-known roadmap of IMO with autonomy levels 0 to 4 and the years that have passed since 2018. Here we are in 2024 and we're almost, I would say, on track with this road plan, because IMO is becoming a reality these days, the full navigation without human intervention. There were very important developments from IMO. In June 2023, we had the MSC's 107th session, and we had the results of the scoping exercise that started back in 2021. Okay. Now, the aim is to have a non-mandatory goal-based mass code from next year, 2025, leading to a mandatory mass code on force from 1st January 2028. And let me go. This is a screenshot. This is the results of the IMO committees. What's important is that we have a continuous and year after year new results coming from the various interdisciplinary committees from IMO that have some important developments. You see here that we have the first in 2021, the second in 2022, and then the third with a joint committee in 2023. Of course, there have been many committees and groups, work groups in other times, but I'm just showcasing that there is a constant development. The things are progressing fast. And what is important is that the joint committee agreed to the following. As discussed earlier, there should be a human master responsible for an autonomous vessel, regardless of mode or operation or degree of level of autonomy. However, the master may not need to be on board, depending on technology, if it will certify use and human presence on board, if any. So for first thing, we might have the master not on board. The master, that's a basic thing, should have the means to intervene when necessary. Another very interesting thing discussed and agreed so far is that the master may be responsible for multiple autonomous vessels. And that gets us back to the scenario that we heard about convoys or caravans of barges that may carry things in rivers or within the port. So one person might be responsible and legally for like 4 or 5 of them. On the other hand, several masters might be responsible for the same vessel on a single voyage, meaning that a master might be responsible to a certain point while crossing the Atlantic, for example, and then another master taking it from there. So all these are very, very new, you see, concepts for us to digest. Also, they agreed that the terminology and the definitions are very important. So this is the first drafts, let's say, and the first ideas of what is coming. So the definition of the remote operation center is now a location remote from the vessel that can operate some or all aspects of the function of the autonomous vessel, and that we can have one or more remote operation centers responsible for a autonomous vehicle vessel on a single voyage. That comes back to the same thing with the masters, that you can have for part of the same voyage different operation centers, but also comes at the safety front, that you can have a backup remote operation center, certified and ready to take on if the first remote operation center has any issue. And even if we had, the onshore seafarers' health issue. So a second remote operation center could take control in these cases. However, only a single remote operation center must be responsible for the vessel at any given time. There cannot be both of them. we said that the master might be responsible for multiple autonomous vehicles at the same time, of course, with conditions, training, and so on. And the definition of a remote operator, which is a qualified person, coming back to the training and CFA and master, who is employed or engaged to operate some or all aspects from remote operation center. Before going to what the classification society says, we already see that we have a kind of a revolution coming from the regulatory front. All those things are never been discussed up to now in the maritime. So EACS, just a moment. The classification societies also take a very close and supportive look to all these efforts, and they will develop their own resolutions and requirements as the autonomy journey progresses. Basically, the classification societies, their job is to produce requirements for the ship makers and the owners and everybody else. What happened a lot in 2023 was testing and pilot programs, as already discussed by all the other presenters. Let me just get you back to the Yara, going working and progressing along the autonomy levels. Many cases of remote operating center, the military application that we saw before, and even cases of autonomous crossings. So in remote control operations, we had companies like Rolls-Royce and others conducting trials with remotely controlled vessels, when human captains, real seafarers, steered the ship from onshore location via secure data links. And the word secure here is very important, as I've seen in my last slide. Short Sea Autonomous Ships Project, Wärtsilä collaborated partners launch trials of unmanned cargo vessels for short sea routes in Europe. Autonomous navigation in controlled areas, navigation with test zones like harbors or ports, or sometimes in rivers. Inland waterways and short sea routes are a very good test bed for all this technology, because it's a control environment and predictable traffic patterns, and very better than the open sea. Okay. And the towing and tag operations, as we heard earlier about sea machines, the trial made. This is a very good example of how it could work, autonomous vessels. Getting back to risk and security, let me stress out how important it is to have cyber secure all these new technologies. It is very important because it's a new, as we say, threat surface, let's call it that is not known to either the IT people so far or the operational people. It's a different level, a different front, because it involves operation technology and many other systems cooperating together, and many command and control systems in different geographical locations even. So the answer to that would be to use AI, to counter-use AI, to get this under control. Traditional systems would not work in this case, as we said, with remote operation center, people on board, so many data links. You cannot just protect one system somewhere and be okay with it. So as we see in this example, we need to have something that can see greater geography, have geolocation alarms, and be able to understand differences in behavior patterns, not only traditional firewalls and stuff like that. And with these few things, I think I concluded my presentation, not to tire you with things that already have been sent. And I give the stage back to you. Thank you very much.
Thank you very much. Thank you for the very interesting presentation. And indeed, it was complementary to all, the previous ones. It was very nice that there were no duplications here, and this is a key, a key factor in such events. Okay, I have a couple of questions for you from the audience. If at some point, I don't see that it will be, very quickly, but at some point we might have, a fully autonomous vessels, which means that it will that we need to have a very, a fully developed AI program or algorithm or platform or reality. I mean, is this possible to have a fully autonomous vessel? Because, we usually use this term autonomous. I mean, autonomy, either you have it or you don't have it. So it's level of automation, and at least from my perspective. But if we are talking about a fully autonomous vessel, I mean, can we have, what do you think about it? And another question is whether we want to have this kind of ships around. Yeah.
For me, yeah, I think the technology is there, and the first front where we'll see the autonomy happening is, of course, the defense front, because the destroyers, that we saw earlier, they do have a protocol that in case that everything goes wrong, they can go up to 6 months without human intervention from the onshore or on board. So actually, that's not the way they work right now. They're always under the supervision, and that's not the way it will work anything in the near future. We saw that IMO will require somebody to be responsible as a captain, as a master for the vessel. So it can also comply to the various conventions and rules and stuff that exist right now, and be insured and stuff like that. The regulation is the main thing. However, the technology is pretty much there. Maybe not so secure. For example, if you just left a fully autonomous vessel right now out in the open sea, I would be very much worried about, you can interrupt its ICE signal, the navigation. You can interrupt in... I don't think all these technologies right now are so secure as to leave them be. However, in the military protocols are much more, let's say, robust. They're not open protocols. Anything is not open. I mean, navigation is not based in the commercial, stuff we know. So there will come the first levels of autonomy. I think it's regulatory and, of course, risk issues. When you have all this fully resolved, I think in many years, and it depends on the scenario.
And Matthew, another question. I mean, I think you touched upon that already. I mean, connectivity and communication capability is very, very important in this kind of vessels. What about if these fail completely? I mean, we are studying and we are doing this, minimal risk condition and fail-safe process. I mean, can you elaborate a little bit on that? I mean, what happens if
I think this has been examined in many cases. Of course, that's autonomy. There should be everything on board should be able to continue operation even with no contact with onshore or anybody outside of the vessel. That's one thing. But let's say it's, as you said in the first presentation, they should be this. They have the same safety and degree of autonomy, at least the same, a little better than if they had humans, because it's the same. If you have humans on board and they lose any contact with the office or the other world, they have no satellites, no Inmarsat C, no VHF, nothing. Then there are certain protocols, what they can do. They cannot actually, I mean, navigate and do their job perfectly. Okay, then they will be based on their vision, the other things. An autonomous ship could do the same, could continue going and see some miles away to see if there are obstacles and maybe stop. I don't know.
Thank you, Matthew. Thank you very much. Gentlemen, we still have like, I said that we will try to prolong it in order, to reach the limit of 2 hours, and we are almost there. This is very, very good, because I think that we had very nice presentation, excluding mine. Your presentations were super. And we had very nice discussion. I would like to urge all the presenters and my fellow panelists, to go to the Q&A and see whether they have a question that I have overlooked and they want to reply to. And at this point, I would like closing this event, which, as I said, was organized by BS Group and sponsored by a Navigation Promotion Center Marinet. I would like to present and announce, or better announce, the results from the poll and ask from my panelists a very, very brief comment on that. First of all, I would like to let everybody know, according to our responses, that our attendees, our audience, at least about 94%, they are at least somewhat familiar or very familiar with the concept of autonomy and autonomous vessels and mass. And this is very good, because it means that, we are transmitting to an audience capable to understand and absorb and integrate what we are saying into their day-to-day lives or expertise domains. But I would like to continue and say that in the question, what do you perceive as the greatest benefit of autonomous ships? Safety and cost savings were the top 2 replies. The environmental factor came quite lower, which is something that it's interesting. Let me just say that my presentation, because I received a couple of questions on that on that direction, my presentation focused on safety, but indeed also the environmental zero emission or near zero emission factor can be a case, especially when we are talking about vessels with increased level of automation in inland water or coastal or shore shipping. So it is indeed very, very, and it's quite tangible. I mean, it can be close in the sense of propulsion technology and alternative fuels. So increased safety is indeed one factor that we are all focusing on. Cost savings is also another one, because we are, discussing that we will not use a lot of personnel on board. We will not have, all that legal claims that we might have on board. On the other hand side, we might need more specialized personnel, but in reduced numbers. So I guess that the replies reflect more or less what we have been talking here. But I would like Maxime, for Maxime to comment on the results on what we perceive as the greatest challenge of implementing autonomous ships. And as if you can see the results, as I can see, the regulatory regime, it seems to be, as I have mentioned, the showstopper here. I see that the technological limitations and public perception and trust, they have a specific percentage, but it's much lower. It's more than 50% regulatory. So if you can have a very brief comment on that, Maxime, it would be very nice.
Thank you very much for giving me the floor. As you asked me, what is the difficulties or maybe some results from the using autonomous ships? I think this is one of the considerations is the reliable telecommunications between remote control stations and vessels. It is that's why if vessels we using near their coasts, we can use standard telecommunications like a cellular phone or maybe WiMAX, or if we use the ships in open sea, we of course we need to use satellite communications. In some of the cases, it could be expensive, and we need a wide channel of the data to provide this information. That's why this is one of the concern of the autonomous navigation. Maybe autonomous navigation don't need the remote control station in some period, but of course it needable one. We can't accept this factor. Yes, and of course the next one. This is provide a sufficient level of visual observation because the remote operator need to good visual observations during nighttime or maybe other bad weather conditions. That's why probably we need to include to the project the thermal cameras or lidars or some kind of to see it clearly, the obstacles or other issues that autonomous navigation can see. And also that maybe not mentioned in this conference, I would add that autonomous navigation is pretty new technologies. Probably this is pretty new sphere. Maybe as you remember 30 years ago, we don't know what is it computer. We only use it for the printing or gaming, and now the autonomous ships we can. We really only find 4 or 5 factors why we need it. Maybe for the safety, maybe for the reducing crew number. But ship owners have to bring to test such technology to understand what is what it for. That's why my opinion.
Thank you. Thank you. Maxim, do you believe the public is ready to accept the widespread use? No, Maxim, sorry, Sean. Do you believe the public is ready to accept the widespread use of autonomous ships? Because, I don't know, it's a balanced poll here. The results are quite balanced, but I mean, the majority, it says no.
Yeah, I think that... So I'll just speak from the U.S. side. So the American public, I mean, I think the American public is still very disconnected with the shipping industry overall. I mean, they feel very motivated to have their voices heard when their packages don't arrive when the Suez Canal shuts down. But otherwise, there's a real, except for some coastal communities, the U.S. public is just not as connected as countries like Norway, for example, to the industry. So in terms of public acceptance, what we do have, we have issues with self-driving cars. We've tried to have aviation drones for some time. That's taken a very long time. So I think that the public perception is, I don't think it's against autonomous shipping, because I just don't think that they as a whole, I mean, it's a very large country, obviously, so I can't speak for everyone, but I think from the public perception, I think if you explain it in a way that makes sense, if you say this will reduce the cost of shipping somehow, if it perhaps reduces risk of pollution, those are the types of business cases that make sense. The public perception, though, that's the hardest to overcome is the labor market. So we have very strong labor unions, which is very different, I think, than some other countries. And that is a huge hurdle. So getting past, because that's not something that is very easy, and you have to be able to convince not only the public but Congress and government agencies that somehow that this will not remove jobs, that perhaps it shifts jobs someplace else, but those are the types of arguments and data and reports that someone needs to develop, I think, on a much higher level. But that's what I see on the U.S. side. I don't think there's an absolute no to it. I think it's more education, and then more use cases are likely needed.
Thank you very much, Matthew. We had another question. The last one was, what level of autonomy do you think is most suitable for ships? And the majority, more than 60% of our attendees, they replied to semi-autonomous, which is more or less human oversight with automated features. A small percentage went to fully autonomous. There was a specific percentage, around 25%, 1 out of 4, that said about remotely controlled vessels. So what's your opinion on that? What we should be expecting?
For immediate implementation, I think I would go with a majority, the mixed mode, which, let me tell you this revolutionary thing. It's already happening. I mean, these days, the new building vessels have so much automation built on them, so much optimization, that actually you're half the master and half the machines are driving the vessel. I mean, almost nothing is direct these days. I mean, navigation to steer the vessel, you have so much automation going back and forth and optimizing. For giving revs to the engine, you also have much automation and optimization and intervention of algorithms. Okay, and in most cases, I mean, the preventive maintenance, for example, the engineer's jobs on board has changed a lot. The new buildings these days, they come connected with a maker, with a man and everybody else, the engine maker, and the job has changed already. So that's the way to go. I mean, future generations of seafarers and future generations of vessels would be further on that path. Many things happening autonomously, surely on automation, automatically, and autonomously, and somebody supervising, prioritizing, and let's say doing the policy on board and conveying the company policy on the systems, let's say. And of course, to be the fallback in case of extreme emergency. Now that's my view, because as I said already, it's already happening. I mean, the engines these days the engineers don't work as they used to work 20 years before.
Thank you very much. At this point, I would like to thank very much our presenters, Maxime, Sean, and Matthew. Thank you guys for very nice and very informative presentations, and thank you for the discussions. They were quite interesting, and I think we learned a lot. I would also like to thank the attendees that they are still with us, and hopefully we try to answer their questions, and hopefully we try to give them pieces and bits of information on this issue, on the issue of mass, because it's a quite dynamic topic that changes all the time, and we are under a very dynamic and vivid environment. So thank you, everybody. Thanks,
thank you
for the organization, and the Promotion Center Marinet for promoting and supporting this session. Thank you very much. Thank you. Cheers.
Thank you. Bye.
Bye-bye.